some of the tools that I've made. We'll start with the first thing that we made in school under our first teacher. And I loved him because he was a throw you to the wolves kind of guy. You know, he'd stand there for hours helping you if you needed hours worth of help. Or he would leave you completely alone and, you know, let you sink or swim on your own accord, you know what I mean? But our second day in class, he had us working on these, right? On the lathe. And then we had to go to the mill and mill the slot. We had a cutter that was just undersized, so we dropped it in, milled our slot, and then moved it over and cleaned up the sides. And this is basically just a spring-loaded tap center. You know, so we had to drill it, ream it, you know, mill the slot, put the taper in the end of it to fit in your center on the tailstock, and it just goes in. You know, and I use this damn thing. We harden the tips of them, just case harden the tips of them with a, you know, with a torch and a tuna can of oil. But our teacher had made one just like this 50 years ago, or whenever, 20 years, 40 years, whatever it was. He was in school, right, when he did his apprenticeship. He made 2 of these, and he still uses them today. So he thought it was a good project, and I agree. This is an awesome tool that I use a lot. You also use it to, you know, if you've got a center punch hole in your work and you're putting it in the forejaw, you put that in your tailstock, put the other end in your work, and put your indicator right on here, and you can indicate off of it as it rotates, because it's gonna, you know, so works for that as well. So that was the first thing that we made. Again, that was all manual. These mill stocks. Around and rusty, but you know, these are just regular old mill saws. They bolt to the table, nothing fancy, but they get the job done. You know, that was our first real mill project. We had to, you know, use our angle blocks and cut our angles and lay them out, you know, with the die and all that good stuff, and you know, so we knew where to take our angles to all that stuff. It was a good little project. First time I ever used a dividing head was on making this little handle here. Made another one just to use the knurling tool. I don't even remember what the hell we made these for, but if I ever need a handle, I got a couple of them ready to rock and roll, I reckon. This is one of the first things that I ever really turned, and this is for that lathe there. You know, I bought it, still had Cosmoline on it because it was so new, and I guess the dude had dropped it, and he broke the down. He dropped the lathe, and he broke the compound, or the, you know, the handle piece. Made out of some cheap cast iron. That's the cross slide nut and lead screw that was in it. As you can see, that's broken right there. So and then it had, as you can see, these little bitty handles on it, and I had this scrap piece. So I turned this handle to press over it, and then pinned it, you know, stuck it in, drilled it, and this is all knurled and stuff. So then I made this, you know, I put a nice little bearing in it. The other one was just, you know, just slid through 2 drilled holes is all it did. So I put this nice little bearing in it. Well, first I made this nut here to fit in there, right? This is just a test nut before I started machining on, you know, brass or bronze or whatever I was using at the time. And I was on one of the little machine forums. One of the older guys just, he basically just ran his freaking mouth about how much time I put into it to make it the way I wanted it. Kind of just stepped on me, right? So I wound up just making some basic ass leaf screw to get in there. You shouldn't let guys get into your head like that. No matter, a lot of these jackasses think they know so much, and they just think they know so much. We're all idiots. Every one of us is a freaking idiot. I don't care how smart you think you are. You don't step on somebody, right? Especially when they're just learning. That ain't what you do. Anyway, so I've changed it from this cheap little fancy thing to 7/16 left hand. I had to turn it down and thread all that. There's my little keyway. Of course, all I did was take an end mill and sink it down in there and put a slot into it big enough for that key to fit into. So now it's much stouter. Of course, it don't go that way. It goes in this way. But whatever. And then your handle just fits right on it. Of course, I put a bigger bolt in it to lock this. But it works pretty well. So this is one of the first real things I had to do. I also had to make me a little compound, 4-bolt compound thing off of Steve Badair or whatever, however you pronounce his name's website. I did it, kind of just do things my own way. I get ideas and then just go make what I want to make. So as you can see, I put a little sight glass in there for you to see what angle you're turning at. And this is all super tight tolerances right here to make this all fit without having any slop into it. And there's a few different things that's going on inside to get all this stuff together. And then this piece, of course, fits down into one of those holes there. I'm making a video. I'm gonna remake this entire handle here because this goes on here, and it's just too small, man. And I can't afford to buy a bigger lathe right now, so I just got to do what I got to do to make this one as comfortable as possible. And so this is what we're working on right now. I turned this piece down and test fit everything to make sure that this was going to be the proper size. And now I'm just going to remake the entire thing. And I'll wind up having to broach that on the lathe just like I did at school. So it is what it is, right? Alright, here's my little plumb bob. The new teacher was making all the students make plumb bobs, and they were making out of hex stuff, hex stock. So I broke out the big old radius turner and put the radiuses in it and used some hand ground high-speed steel and put radiuses in it. I don't really have any use for a plumb bob that I've never used one before. And then they were just drilling a hole in and tapping it and then taking a bolt and center drilling it and threading through that. And me, I put this up in the middle and drop my angle in like that so I can bring my string in and tie it, and when you pull it, it just kind of cinches up inside that. I think you get the idea what the hell I'm talking about, right? So we'll just carry it. And here's just a down and dirty angle block I needed to get a job done here at the house. Just needed to get it done. So, and I needed a way to hold it, so I just took a piece of scrap aluminum and made a frickin' angle, right? And of course you got my little jacks that I made. These are all made manually on the lathe. Big brother, little brother. This one will probably go up to about yay high. This one will probably go up to about yay high. So they kind of bridge the gap for each other, I guess you could say. This is all stainless steel here. And let's see here. What else did we make? Here's my little radius turner I made. kind of like the one that they gave away for the toolbox giveaway, except mine's all made out of scrap scrap metal. Again, this came off Steve Badaire's site. This adjusts in or out, you know, so it'll do concave and convex radiuses, and it just fits the triangle inserts that I have. You know, I made it to where it fit the triangle inserts that I got for my little cheap turning tools. So I made this under the first teacher. And we got some more 5C collet stock. This is the first one I made, and I screwed the pooch. My retarded behind. I drilled it to the size I was supposed to be threading it to, right? So I keep this, and you'll see here I keep a lot of lessons. I don't, when I scrap something and it taught me something, I try to hold on to that part. You know, sometimes you just scrap something from being stupid, and sometimes you just scrap something because it just, you're new to something, you don't know no better, right? And that was the case with this. You know, this was also the first thing I ever threaded. So I'm pretty proud of them threads, but then my retarded behind drilled it too big. It still works. It just works with a much larger bolt. You know, we were supposed to be making these right here, which this end threads into the back of your 5C collet, and then this is basically your stock right here, you know. So, I mean, I got these two, and then I got another one that someone else made that was in the trash. And you'll notice I take a lot of crap out of the trash. They threw away a lot of good stuff. At least good stuff to me, you know. And I'll take it. So there's my 5C collet stuff. And we also had to make this. The rest of the students, the teacher, they brought their parts in, and the teacher welded it together. And this, your 5C collet slides in here, and you got a little tang in there. You had to mill this rod, put the right size tang in it, and that fits the keyway in the 5C collet. So you hold it with this while you tighten it with that. So it's basically a set is what we got here. You know, I welded this myself because, you know, I mean, I know how to weld a little bit, I reckon. Okay, so we made them, and again, most of the projects I've made are real world. You know, at school, people walk in with jobs, and we do their job and then send their job back out to them. So most of the stuff that I've worked on has either been at the cylinder head shop, machining stuff that's actually being used, or at the cylinder head shop, dental restoration / manual machine shop, I guess you could say. But and the same way at school, and the same way here at the house, you know, even after I went back to school, I was still doing the manual machining for the cylinder head shop. I was just doing it on my own machines. But they would give me the tools to tell them what needed to be done, and I would make the parts that they needed made. And even when we were there, sometimes I'd have to bring work home because they just didn't have the right end mill, or, you know, whatever the hell the problem was. This was the first mandrel I made. You know, it's nothing pretty because I'm just using scrap, you know. This is turned to the right diameter, that's turned to the right diameter. This, you're holding it to chuck basically like that with a bolt that goes through it, the bolt together. And what that did was it held this centerpiece right here. This is a wind chime that I was making for my mom, right? And, you know, I use hand ground high-speed steel to put all the radii in here, and then buffed it all out. This is all on the lathe. This piece here is actually 3 pieces because we didn't have enough. So this stuff is all turned to the right diameter, then press fitted together, and then actually machined as one piece. The same thing with this. This is 3 pieces. And again in here, for the center chime, you know, all this would unscrew. That would unscrew, and you tie all the chimes behind it. But for that center, for the center knocker, I made this little plug that just threads in. So you tie off to that, and then you would just slide the string and all that in, and just screw it right back in like this. I just thought it was a little bit cleaner. You know, a little bit cleaner looking. you screw it in flush, it looks like one piece. The same way with this unscrews and you thread it in, that way you don't have any string tied on the outside of the wind chime. But I took this on the big 17-inch Tornado, which is my favorite lathe, and threaded it on the slowest threading gear that they had. You could see where I was threading right across the aluminum. So I needed a way to turn that. So I had a live center. I center drilled the bolt that was holding it together and had a live center in it. So I was turning it basically like this, chucked here and in between the center right there to get that threading done. And on the wood, basically I had just a square chunk of wood and I just put it into the damn lathe and indicated it and made what the hell I needed to make with that, right? Now the chimes for it, I basically just threaded, I just picked 3 different, super fine, super coarse, and then something in between. And I threaded each one of them, 2 of each style. And I found a wind chime website, some dude that, that's his thing, is making wind chimes, right? So he's broken it down to a science. I didn't say anything with my suspension. You can't just hand somebody some half-ass crap, right? Wind chimes are supposed to sound good, so there's a science behind that. So I went and found the science, found the right type of keys, cut these all the right length. You got to cut them the right length, and you also got to put. Now I turned pins and drilled and pressed them in and all that crap to hold these strings, so all of it's internal, right? But how far these are from the top, as well as the length of the chime and the material that it's made out of, thickness of the wall, all of that stuff plays a factor in the tones that you're going to get out of them. So you're going to need to pick the tones that you want. I mean, of course, you just go at it and just do it, and you might get it, right? But there's a website out there for that if you want to do it right. So there's that. Let's see what else Chuck's made. The mandrel. This is just a crucible. I got a whole bunch of, probably about 1,000 pounds of aluminum out there, cast aluminum from dental chairs and stuff. Again, they were throwing it away. I'm taking it, X-ray machine. I'm taking everything. I want everything you got, right? I can melt it, sell it, do something with it. But anyways, this is just a big ass. It was just a big old chunk of 4140. I just turned it down to melt crap in, right? So then, I got 1, 2, 3 block. We use it at school. And when I made the 1, 2, 3 block, I made this at the same time. It's a step block. Yeah, so it's 1, 2, 3, but it's a step block. So it's 3/4 inches one direction, 1/2 inch the other direction. The step that's on it. I just wanted to do something different, so I made them basically as a set together. Ground them together, machined them together. All the typical crap. Now here's some mistakes. Like I said, I keep mistakes, right? So each one of these has its own mistake. You can see the holes were supposed to be centered, they're not. Got a tool that dropped in right in the middle of this frickin' thing. Holes drilled off center. Broke some drill bits, things like that. This one, broken drill bit in it, and all of these taught me a lesson. Every one taught me a lesson. This one right here, I just made this for my wife's birthday, and it says I love you. It's not in this one, but it was engraved with I love you across here. And I don't know, any home can be a castle with the king, queens, and love. But you can see the tool that was supposed to be going 3 thousandths deep went all the way through the part, or gave it a good try anyway. So you shouldn't trust other people's tool offsets on those machines either. So, that's a good lesson. I scrapped 4 of these. Her birthday was Friday. I started working on this Friday morning. I scrapped 4 of these, but I got the damn thing done and to her. And then I took red crayon and colored it all the lines. Of course, this is rough. This is where I got my feeds and speeds right with this finish. But because even after I ran the things, I just ran the part on top of it because this was scrap already. So you might as well do your first test run on the piece of scrap that you've already created yourself, right? So I took that crayon and colored it in. Then I melted it with the lighter, and then I wiped it all off. So all the engraving was in red, right? Flywheel for a little air engine. Just step overs, you know. You don't think how much of a cusp them ball noses are going to leave until you start running them. So learn your lesson. Little gear that I made. You know, you can see the little mistake down in there. You see the mistake here. The main teaching thing with this is lead in, lead out angles. Vertical and horizontal lead in, lead out angles. You know, you really gotta watch your tool diameter when you're dropping in. Okay, what else do we got? This one here, I don't even know what the hell happened. It ran the perfect program and then it just dropped in on the inside of the same path. It just ran and started running the same thing on the inside. So, I don't know. And I made this for my son. This old axe head. He liked that Minecraft crap, so he wanted something to play with. So I made him that to go beat in the yard. As you can see, it's used, good and used. The cylinder head shop helped to come up with this. Basically, that hooks into your air line. That turns your air on right there. This controls your fluid to air ratio. And then this is just, one will be air and one will be coolant. You know, you just hang the sucker wherever the hell you want. We did that, and then we also had these foot pedals. Of course, this one needs to be screwed back together, but basically you just hook one end of this line to your air compressor and the other end of your line you just hook to it. I like to use it on the lathe because I can put the little air nozzle right up with the boring bar, and then I just step on it and just whenever I need to add air to it. You can do the same thing with this kit here. You just turn off your coolant and just run the straight air through that as well. I mean, you don't need to use the gun. You can hook that straight to the straight nozzle if you just want just a straight mister or even flood coolant. Of course, it's not going to flood. It'll be more of a dribble, you know, just a kind of running on top of the part type of deal. And the most recent thing that I made, some of y'all probably seen the videos, I made my fixture plate. You know, basically the way I went about doing it, you know, I drew it up in CAD and everything, but I took me a big old chunk of aluminum. I squared up two sides, then I dropped it on the machine. I indicated in this side, so it was clamped and clamped. We machined here and here, did all the drilling and tapping. And after everything was done, some of you may not know this, but you can run a CNC machine just like a manual machine. So what I did was I took my cutter in and I just dropped it down manually, came over to it, ran it over until I touched off on it, just like you do on a manual machine, and just ran it across it, right? Whatever RPM you're wanting to run, you do all that stuff manually on the CNC. You know, I use it manually all the time, so this ought to come in handy quite often. So those are some of the projects that we've done, and most of that was done manually because I've only been messing with CNC for, you know, a few months. Most everything I've ever done was the hard way, but I digress. I'll just be a button pusher, right? Because There's no skills in CNC logic.